So I just want to review on naming chemical compounds so you can get ready to take a test. And once this has been completed, you'll then be able to start the test. And I should post that within the next day or two. So we've been working on throughout the year so far naming chemical compounds. And there's a few questions when you're naming them that you have to ask. Okay, so the first one is always, is the compound ionic or covalent? So again, when we're talking about a compound, we're talking about two things that are joined together through a sharing or an exchange of electrons. And then we have to figure out once that occurs, and we see here we got there's something called a binary, which is two, and here we have that sodium and chlorine. We have carbon and oxygen, and we have magnesium and chlorine. And really, we're just looking at binary compounds, and we'll get more and more complex as we go along. But so here we have these compounds. The question, is it ionic or is it covalent? Because if they're ionic, they're exchanging. I'm just going to add that, exchange electrons. So one gives, one takes away, and they form an ion. This is terrible writing. Okay, and one shares, that's covalent. And we then show these different things, that one is ionic or the other one is covalent by doing some different things when we name them. So the first question, ionic or covalent, right? And to answer that question, all you have to do is look at the periodic table. And where are those compounds? So if we had the first one, NaCl, we have to look at this one, the first one. We ask ourselves, is it a metal? Okay. And then we have to remember where the metals are. These first two are metals. This group here is a metal. And so all these are included in that. The ones that are non-metals kind of go this little blue area right here. These are halogens, so they're non-metals too. These are non-metals as well. They're gases, inert gases, noble gases, but they generally don't form compounds, so you don't worry about these. So you're really asking yourself, Na, is it one of these blue, light blue, or is it something else? So let me go here. Here's sodium, Na. And then, so we know it's a metal, so we know it's ionic. The other one we have there is, if we go back here. Yep. So we know this is ionic, right? We'll put an I over it. And then C2O3. We then go back. We'll just put this one up here. C2O3. So we're looking at carbon. And here's carbon. It's not a metal. It's a non-metal. So that tells us it's covalent. We'll put that above it. And then the last one, we're looking at magnesium, MgCl2. And eventually, as you're doing these, you kind of get the idea of right away, is it ionic or covalent? You kind of figure that out right away. So if I just put this one in MgCl2, and Mg is right here. So it's a metal. So we know it's ionic. Okay. So that's kind of our first question we've answered, right? It's ionic. Okay. And then if we look at the next question, we're just going to kind of pull this down and we'll come back to these. The next question is, should I use prefixes? If it's ionic compound, this is just something you have to remember. If it's ionic, you do not use them. Don't use any prefixes. If it's covalent, you do. You just have to know what they are. There's di for 2, and I gave you a little pink sheet. There's tri for 3. There is tetra for 4. You just kind of have to have that pink sheet until you learn them, and so on. It goes all the way to 10. So just make sure you have that sheet, okay? So then if we go back, knowing if it's covalent, we use prefixes. If it's ionic, we don't. Okay, so then, and really we just name the compound, the first one, when we're doing these. Doesn't matter which one it is. So sodium. Then for the second one, we just drop the end of the name. This is chlorine. We just drop the INE and make it ide. It's sodium chloride. No prefixes. And really, we don't see any. The prefixes really refer to the subscripts, or superscripts, I'm sorry. The subscripts there, I'm right. So the next one, we look at carbon, right? We determined it's covalent. We're going to put its name a little further down. So we have 2 carbons, so we're going to do dicarbon. Same thing we did the first one, except we use prefixes. Dicarbon. And then oxygen has 3, tri. And then we're going to have oxygen, but we're going to put the IDE on, trioxide. That's the covalent one. Then we have this one, magnesium. Again, it's ionic, so we just write magnesium. Yep. Magnesium. And then chlorine, it's chloride. And you see here, we do have a 2 after chlorine, but it's ionic, so we don't use any prefixes to denote this subscript. So it's magnesium chloride. So those are your normal ones, ionic or covalent. There's one other condition we've kind of been looking at the last couple class periods. Is it a transition? Okay, so we're going to go back to the periodic table here and look. So a transition metal is found in the middle, and they have multiple options for the charge, so they kind of have to tell you what it is when you're naming it, or you have to say what it is when you're naming it. So if we go back to here, FeO, so we have to look and see, is it in the middle part, right? So this part right here is your transitions. These are the ones that have multiple charges, and here's iron. Iron is a really common one. Copper is a really common one. What else? Vanadium, you'll see that one quite a lot. Tungsten, pretty common. Silver, I think it has it's just one. Don't worry about that one as much. Those are your main ones: copper, iron, vanadium, and tungsten. Scandium too, I guess. Some of these top ones, cobalt. These are kind of the first row. These other ones are kind of rare. But really, it's iron, vanadium, copper, cobalt, and tungsten. Okay, so we know that iron is. So then we then have to remember that idea that it is a transition, and we have to let it be seen in the name. Okay, so here we have to analyze it a little bit then, because we have to figure out what is the charge of iron. And we know that if we look at oxygen, it is -2 because of where it is on the periodic table. That would then cross, but we don't see a 2 here. So it must be that the iron gave us a 2 that canceled it out. So it must be +2. Okay. So then we have to state this in the name. So we call it iron. And we use Roman numerals, 2 oxide. And again, we just drop the ending and IDE name on it, right? So iron 2 oxide. This was a tricky one because it's hidden, because we don't see the 2 for the oxygen. So it can be a little bit harder. But here's the next one: cobalt and chlorine. Okay, here, this helps us. We know that chlorine is going to be -1 because it's in group 17, not 3, -1. -1. Okay, and then we know this 3 comes from cobalt, so it must be +3. So we're going to name it cobalt. 3 chloride. That's how you do that one. And then if you see them named with a Roman numeral, then you know it's transition. This tells you the charge. Okay, the other way, if you go the other way. So then the last one's manganese. Again, we have the charge here. We know bromine, and these halogens are going to be really common to form compounds. It's group 17, it's -1. We know this 2 goes with manganese, it's +2. So we then know manganese. It's a 2, so we got to state that in the name. And then it's going to be bromide. Okay, and then just keep in mind, so it may not give you the formula, it may give you the name. Then you're just going to know that whatever this one is going to be the charge of the first element. And then the second one is just by using the periodic table. Okay, so go ahead and try some of these practices. And then once you've completed this, you'll be ready to take the test. And let me know if you have any